Alright, welcome back. So here we are in Cyberpunk 2077 on the 2023 Alienware M18 R1 with the RTX 4080 featuring 12 gigs of VRAM. We're going to be doing some testing here and benchmarking in Cyberpunk 2077 as well as doing some gameplay. We'll start off with our ray tracing set to Ultra, and we'll leave DLSS frame generation off for now. We'll also leave DLSS off for the moment. We'll leave all of the settings set to high or ultra, whichever the maximum option is for each of those game settings, and we'll just crank up our ray trace lighting to psycho mode, and let's run this benchmark. Let's see what is the performance from this RTX 4080 in this Alienware M18 R1. As you probably know and probably have seen from my other reviews, the RTX 4060 and 4070 don't go above 100 watts. Though they're promised to reach max TDPs of 140 watts, they never get there. Thanks to Jared's Tech for pointing out that there's a 1 volt limit on those graphics cards, and when they hit that, they pretty much stop adding any more performance. I don't know what the physical reason is for that limit, but what that means is basically we're getting 100 watts of performance out of those GPUs. This promises 175 watts, and as you can see here, we're well up there, 160, 170, 175 watts. And it's toggling between different wattages up there, but we're getting very close to what the maximum allowed wattage for this GPU in this device should be. So a much better gameplay experience, 74 FPS with everything cranked, ray trace lighting set to psycho mode, and other than that, the ray tracing ultra preset applied here. I think this is a great showing for the RTX 4080 in the Cyberpunk 2077 game. This game is still very, very intensive on the GPU. It's not very well optimized either, though they've gone through some significant patches in the 1.5 gameplay patch that provided texture fixes and a lot of improvements to the engine, have made this game much, much more playable. It's still a little bit of a dogfight. So you can see here the average FPS on that run was 68. That's acceptable, I would say, but for a 4080 that's running at 175 watts, I really would have expected a little bit more. So we'll turn on some of the DLSS goodness and the frame generation goodness to see, what this, where that frame rate jumps to. NVIDIA has promised quite a bit, doubling of frame rates with the frame generation turned on. So we'll enable that here. We'll leave everything else set to Ultra Ray Tracing preset. As soon as you change something else, it changes to custom, but I can assure you that the preset that's selected here is Ray Tracing Ultra, and then on top of that, I've turned on frame generation, turned on DLSS Super Resolution, and set it to quality, and we'll leave the default sharpness of 0.05 to on. Make sure that AMD FSR and those goodness things are turned off. All of the ray tracing will stay turned on and will stay in psycho mode for the lighting. Let's rerun the benchmark for another run and see how this game performs. So the promise of DLSS frame generation is that it doubles your frame rate by inserting frames that are AI generated between the actual frames of the gameplay that are generated by the engine. So that allows you to basically double the frame rate essentially, or theoretically, and it seems to work in many games. So as we can see here, we've now jumped up from about 60, 65, 68, 70 FPS to high 80s or maybe in the low 90s. So I would say that is definitely a significant improvement. We've got 50% plus bump to our frame rates here, and visually the game still looks stunning. There's no artifacting or anything that I can speak of that would say that frame generation has a negative impact on overall visual quality or fidelity of the game. There is a little bit of texture pop in here or there, but they're so small in particular areas of the game that you probably won't notice it as you're running around and just gameplay. This is a benchmark, so it's a little bit slower paced, and it's easier to catch things that you would otherwise miss as you're running around in the game world and doing whatever. So we can see here that at this point it's getting into that triple digits, so 103, 5, 7 FPS. Fantastic. That means we are going beyond now 50% improvement and getting closer to that 100% or the doubling of frame rate that they've promised. There we go, 115, 113 frames per second. Yeah, that's pretty impressive stuff indeed. So our average frame rate has now jumped from 68 to 105 frames per second. Impressive indeed. Well done, NVIDIA. There is a counterpart to this coming from AMD sometime later this year. I don't know, they announced these things 6 months in advance, and AMD is always late to the party because they're just so focused on server hardware and server goodness, because that's their cash cow right now. So when that comes to the table, it will be very similar to what NVIDIA is offering with frame generation. So don't feel bad or left out if you don't buy an NVIDIA GPU and you want to wait for an AMD. You'll have similar tech and exactly similar, hopefully levels of performance available on those GPUs. So now what we've done is left ray tracing turned ray tracing off, just gone to ultra mode. So now we're just testing rasterization performance of this GPU. We'll turn off DLSS. None of that goody stuff. All of the basic settings will stay to ultra. We'll leave ray tracing off, and let's run the benchmark. So this will give us an apples to apples comparison when we're comparing against AMD GPUs, for example, or perhaps even Intel GPUs, to look at just the raw rasterization performance. That is the ability for the GPU to render these frames without adding ray tracing or additional post-processing effects to your display. So let's see how this fares. So very similar, I'm a little surprised actually, very similar performance to what we had with ray tracing set to ultra and ray trace lighting set to cycle. How is this possible? I'm a little baffled actually. Our figures should be much higher because now we're just rasterized performance. Okay, 70, low 70s there. What is impressive with the RTX 4080 is if you look at the frame time, which is the second figure next to the last line of those figures that MSI Afterburner is putting on the screen with Riva Stats Tuner, we've got 93 FPS, but then the second number, it's often staying in the single digits. So that means the frame time is excellent. This GPU is pumping out frames without much delay between them or without much lag. On the 4060 and 4070, I regularly saw double these figures, so 25, 28, 23 into the 20s, so perhaps even jumping into the 30s for very brief moments. So the fact that this GPU can push out this many frame rates and that quickly is very impressive indeed. So 73 FPS for rasterized performance. Our DLSS, or excuse me, our RT cycle performance was 68 without DLSS. So neck and neck, perhaps a 5% difference with just raw rasterization performance. In that case, I would say don't even bother turning off, the ray tracing. Leave the ray tracing on unless you have a very low-end GPU, such as maybe a 3000 series 3050 or 3060, or maybe even a 4050. I'm not sure. That's one GPU I have not tested yet for the 4000 generation. Hopefully, I'll get my hands on one very soon here. So now what we'll do is we'll leave it to ultra. The only thing we will add this time is turn on the frame generation to let's see what that NVIDIA magic can do for us. We'll set the super resolution to quality, and we'll leave everything else off as it is, and ray tracing will stay off. We'll make sure that all of our settings are set to high and ultra and nothing has been toggled accidentally. And let's run this final benchmark. After this, we'll jump in and do a little bit of gameplay here, see how it works when we actually roam around in the game. I haven't gotten very far into this game because I found it, frankly, to be poor in terms of the gameplay experience. Visually, it looks fantastic. It's stunning. It's a beautifully, drawn up, imagined world. But for some reason, the gameplay just did not appeal to me. The gunplay was even very finicky. It felt like the enemies were, bullet sponges like we had with the Division and the Division 2 from Ubisoft. I was very turned off by that game when it released. I had very, very high hopes when the original Division was released and showed off at E3. I was really hyped for that game. When I got it on launch day, played it, and I said, this is, such a mess. I mean, they did clean that up, but it just still feels like, the enemies are just bullet sponges. Of course, it's no Call of Duty, so you can't be hyper realistic. And that's just a different play style. Excuse me. So now we can see here that consistently, no matter what mode we choose or what settings we apply, we're regularly hitting up to those 160, 165, 70 watts. So, and in this case, with true rasterization performance, we are actually seeing doubling of that frame rate. So you can see here 70 FPS, we're often up in the 130s, which means 140 would be exactly double. There you are, 150 FPS in this particular scene. So DLS frame generation, guys, does work. It is a little bit of black magic. Use it. 130 FPS average. Now let's jump into the game, do a little bit of gameplay, and see how the experience is on Cyberpunk 2077 on this Alienware M18 R1 with the RTX 4080. All right, loading. Yeah, the frame times are very, very impressive on the RTX 4080. I wonder if it's a similar story on the 4090 or if it even goes lower. Right now we're sitting at 3 3-4 second frame times, which is amazing. If only this thing could push 340 FPS. But if you look at that VRAM, we're right up at that 8 gig limit. So if you get a 4060 or 4070, you're going to hit that limit quite hard. In this case, you can see it's going well above that. And if you scale some of the other settings in other games, I'm sure you can really hit that number up to maybe 10 gigs or even higher. So 12 gigs of VRAM for a 4080, I think, is the bare minimum that NVIDIA has given us just to get away from saying that they've only given us 8 gigs of RAM. Otherwise, there would have been a lot of backlash there. So one final test here, we'll turn on our in the gameplay itself, we'll turn on some of these settings and toggle between them, see what the effect is. Let's turn all of the ray tracing goodies on again and see how the gameplay and the frame rate is affected here. So now I'm just roaming around in the game, looking at the lights, looking at the pretty things, seeing how the frame rate is toggling up and down. And we're still hitting in the 90 FPS range. I think that's very good performance for 150, 160, 175 watt GPU in a laptop. And that's running, I mean, it's hot, but it's running fairly cool where the WASD keys are. So it's a decent machine. Alienware always comes in hot and heavy, but gives you that performance. And man, have they given us the performance here with the RTX 4080. I am very tempted to swap out the 4080 model for the 4090 version, but that is another $650, and I haven't quite decided yet whether I will make the jump or not, since I don't have actually a lot of time for gameplay. So that's about it. I think that'll wrap it up here. Thanks for watching this gameplay clip and some benchmark testing, some quick benchmark testing of Cyberpunk 2077. See you in the next one.